Hello students, welcome back to lecture 10 IP addressing scheme and hierarchy classes. Last class we have seen what is IP addressing and what is subnet mask and what is subnet address. This class we are going to see IP addressing scheme and hierarchy classes on IP addressing unit 2. So we will see that content of the lecture IP addressing scheme and hierarchy classes. There is a different classes, class A, class B, class C, class D, class E, that comes under the classful addressing and classless addressing. First of all, we will see that IP addressing scheme. So every IP header has 32 bits that assigned for addressing a desired device on the network. So an IP address is unique identifier, so that is used to locate a device on the IP network. So how many devices on the IP network? So the individual IP address that is uniquely identify the particular device. Example, you can see there 192.168.0 and 12 means it will identify the particular device on the IP network. So this IP address, to make the system scalable, and the address structure is subdivided into two network ID and host ID. So the network ID is that is identify the network, so that is devices belongs to, and the host ID identify the device. So network ID identify the network, which device that is belongs to, and the host ID identify the devices. So this is implies that all devices belongs to the same network have a single network ID. So here this is the classes of IP addresses. So based on the bit positioning assigned to the network ID and the host ID, the IP address further that is divided into different classes, that is class A, class B, class C, class D, class E. So here the class A is now start with the 0 followed by 7 bits of network ID and 24 bits of host ID. So the range of this class A 1.0, 0.0 to 127. So 127.255.255.255. So simply we can say 1 to 127 is the range. And class B that start with 10 and followed by 14 bits of network ID and 16 bits of host ID. So the range of this IP address, that is 128 to 191, which means 128.0.0.0 to 191.255.255.255. So this is class B. Class C start with 110, that is followed by 21 bit of network ID and 8 bit of host ID. So that range of IP address 192 to 223. So means 192.0.0.0 to 223.255.255.255. And the next class is class D. So the class D start with 1110 followed by 28 bits. So this class D is used to only for multicast addressing, by which so group of host form a multicast group and each group require a multicast address. So this range is 224 to 239. So 224.0.0.02, 239.255.255.255. So next one is class E. The class is start with 1111. So the followed by 28 bits. So the class is reserved for network experiments only. So the range of this class is 240.0.0.0 to 255.255.255.255. So this is the no IP addresses that is divided into different classes. So based on the bit positioning which is assigned to the network ID and host ID. See, next we will going to see that hierarchy classes. So the transmission control protocol and the internet protocol that's defined the five classes of IP address that is same which we have seen just now, class A, class B, class C, class D and E. So each class has range of valid IP addresses. So the value of the first octet. Octet means it is nothing but sequence of 8 bits. So that first octet determine the each class. So IP addresses from the first three classes, which means class A, class B, and class C that can be used for host addresses, and other classes that are used for the purpose of multicast purpose and the experimental purpose. So that means the class D for multicast and class E for experimental purpose. So the system of IP address classes were developed with the purpose of IP addresses assignment. So the classes created were based on the network size. For example, for the small number of networks with a very large number of hosts, the class A was created. So likewise, other class also created. Example, class C was created for numerous networks with a small number of hosts. So there is a different purpose the classes was created. So hierarchical classes, you can see here the class A, class B, class C, class D, class E. So class no A having no byte 1 and so network ID. So the small number of network ID, the large number of host ID. And class B having the network ID and the host ID is a equal range, and class C having the large number of network ID and a small number of host ID. So class D having that multicast addresses, and class E also it is used for the reverse ID. So here there is a formula to know that is calculate the number of networks and the number of hosts. So a number of networks and a number of hosts or number of networks that can be calculated based on this formula. So here that addressing we can call it as no classful addressing and classless addressing. So classful addressing nothing but it's allocation the method that allocate IP address according to that five major classes. So that network ID and the host ID also depending on the classes. So classful addressing that is categorized the IP addresses into five major classes. So class A, class B, class C, class D and class E. So first we will see that class A addresses. So class A addresses that is IP address belongs to class A address that assigned to the network that contain a large number of hosts. So here the first bit of the no first octet that is always set to 0. You can see these images. So the first octet range is 1 to 127. So that is binary, no 0 0. There is a 7 0. Then the least significant bits 1 2, that the most that is first 0 and all 1. So 1 to 127. So the network ID is 8-bit long and the host ID is 24-bit long. So the default subnet mask for class A is it is starting with 255 dot next it will come other numbers. So that's what that is default. 255 is default. So we can assign other number whatever no that is based on needs. So here always the high order bit, that is first octet in a class always set to 0. So the remaining set bit of the first octet that are used to determine network ID. So the 24 bit of host ID are used to determine the host in any network. So the default subnet mask which I have set now the class A is 255 point x point x point x point. So that you can see even the class A addresses also that is include no that is IP address starting from 1 to 126. So the range of the IP address no 127. So that is one of the this range of the IP address 127 is also reserved for loop back IP addresses. So this is the class A addresses. Class B addresses. An IP address which belongs to class B has the first two bits in the first octet set to 10. So the IP address no that is that belongs to the class B that are assigned to the network that ranges from medium size to large sized network. So that no you can see here the second octet ranges from 128 to 191. So that the binary value 1 no most significant bit 1, other than most significant bit all no bits are 0, then hyphen 10111111. So that means 128 to 128 to 191. So the network ID is 60 bits long and the host ID is 60 bits long. So no both are equal. So the you can see that images you can understand. So what is the default subnet mask for this class B? 255.255 that is default subnet mask of this class B. So always that IP address range, example of IP address range of this class B address, you can say here 128.0 points and you can 1.5 whatever you can give, but 128 point no 0 point xx all that is default to up to 191.255.255.255 we can use that address. So this is the class B addresses. Now we are going to see class C addresses. So class C addresses that is no assigned for small size networks. Small size networks. So this IP address always belongs to the class C. No, that are assigned to small size networks. So here the first octet of class C IP addresses has first 3 bits set to 110. Thus the third octet range from 192 to 223. So in this no we can see that is no 21 bits of network ID is little no large network ID, and the host ID is 8 bits. It is not only for the less host ID, so it is only support for the small network. So the IP address ranges in the binary form 1100 000002 110 so which means that is decimal format 192 to 223. So that is nothing but 192 point, so we can assign another number. So 0.1.5 to 223 point, that means 255, 255.255. So here the default subnet mask for class C is 255.255.255 point, any other numbers, example X. So this is the default subnet mask for class C. So next one, that is class D. So class D, that is now only for the reserved address, that is for multicasting. So the high order bit of the first octet of IP address, that is belongs to class D. So that are always set to 1110. So the remaining bits are the no address that is interested host recognized. So here, see here, the third octet ranges from 224 to 239. So the binary format, you can see that from the most significant bit 111000002 and followed by 1110111. So what is the decimal format of this one? 224 to 239. So the class D is always reserved for multicasting. So what is the IP address range of this class D? 224.0.0.02 to 239.255.255. So you can see this images, it will clearly shows that class D address is only for the purpose of multicasting. Now we will see the class D addresses. So the class D IP address that is belongs to class E, that is for the reserved for the experimental and research purpose. So that is only for experimental purpose or research purpose. Okay, so this IP addresses of class E ranges from 240.0002 to 255, 255, 255.254. So this class doesn't have any subnet mask. So the high order bit no, of first octet of the class E always set to 1111. So here the class doesn't have the any subnet mask. So this is the class E addresses. Now we will see that comparison of different classes and its address range and its support. Class A, the range, address range is 1.0.0.1 126.255.255.254, and this class A is support no millions hosts on each of 127 networks. And class B, that is no range, address range is 128.1.0.1 to 191.255.255.254. So that is support to 65,000 codes on each of 16,000 networks. And class C, the address range is 192.0.1.1 to 223.255.254.254. So that is support to 254 hosts on each of 2 million networks. So and class D, that is address range is 224.0.0.0 to 239.255.255.255. So that is support to reserved for multicast groups. So finally class E, that is address range is 240.0.0.0 to 254.255.255.254. So that is support to reserve for future use or research work and other no study purposes. So classless addressing, it is nothing but no IP address allocation method that is designed to replace classful addressing, that is to minimize the rapid accession of IP addresses. So it is more practical and useful, and there is no boundary on network ID and host ID. So the classless address is also called classless inter-domain routing. So summary of this lecture, hopefully in this presentation you may have learned that introduction about Internet Protocol addressing scheme and its no different categories of IP addressing hierarchy classes. So this is the reference books are available. You can go through these books and get lot of information from these books. Thank you.